we have talked about the bottom of the framework, of the stack. We've talked about HDFS, and we talked about Yarn or MapReduce version 2.0. As you can see, on top of these things are several different pieces or architecture, and they have evolved over time. So let's look at the history and look at how the entire ecosystem has evolved and grown over time. As you might have noticed, a lot of these applications have different kind of funny names. And so how can we figure out the entire zoo? And how can we figure out which one of these applications does what? What is it used for? Is it a SQL-like environment? Is it where we submit jobs? Is it how we access our data? What can we do with all of these applications? So let's look into each one of them in details. So we've talked about that the roots of Hadoop go way back into Google's big table and different kinds of applications that started working around that idea of how do we scale and distribute and process very large amounts of data. So here we have the original Google stack, as some people refer to it. And what they did is they started with the Google file system. They thought that it would be a great idea to distribute a large amount of pretty cheap storage and try and put a lot of data on there and come up with some framework that would allow us to process all of that data. So they had their own original MapReduce, and they were storing and processing large amounts of data. Then they said, well, that was really great, but we would really like to be able to access that data and access it in a SQL-like language. So they built the SQL gateway to ingest the data into that MapReduce cluster and be able to query some of that data as well. Then they realized they needed a high-level specific language to access MapReduce in the cluster and submit some of those jobs, so Soswell came along. Then Evenflow came along and allowed to chain together complex workloads and coordinate events and services across this kind of a framework or the specific cluster they had at the time. Then Dremel came along. Dremel is a columnar storage and a metadata manager that allow us to manage the data and able to process very large amount of unstructured data. And then, of course, you needed something to coordinate all of this. So Chubby came along as a coordination system that would manage all of the products in this one unit or one ecosystem that could then process all of these large amounts of unstructured data seamlessly. Well, then we can see that Facebook's stack looks very similar. You have ZooKeeper that orchestrates things. You have HBase, you have High and DataB, and then we have Scribe that is used for ingestion of large data sets. Then if we move on and look at the Yahoo stack, you can see that they will use some of the same components, but they have something called Data Highway and Uzi and in HCatalog for the metadata catalog. So things are still very similar. They're still used for the same purposes. However, they might have different names because they have somewhat different implementations of these tools. Moving along, you can see LinkedIn has their own version of this stack. Again, you can see that there's some of the same components, and then there is some specific versions of these tools that these organizations developed on their own. So you can see that there's a pattern that emerges across all of these stacks that different organizations use it. And now we can see that we come down to the Cloudera's distribution for Hadoop, and we can see which one of the pieces of the system Cloudera has. So you can see that in Cloudera's distribution for Hadoop, or Cloudera stack as we call it, we have Scoop and Flume for ingestion. We use HBase for the column and store. We have Uzi as a coordination and a workflow engine. We use Pick and Hive for high-level languages and querying some of the data. And then we use ZooKeeper as a coordination service on bottom of this stack. So we decided to use Cloudera's distribution for Hadoop because they have this really excellent quick start VM that you guys have already downloaded in the previous class, and we can do all kinds of experiments on it without having to spend the time either begging our IT guys to install a full installation of the Hadoop stack or having to spend time doing it ourselves. This VM is structured in a way that enables us to run all of these different services and learn how they work without a whole lot of back-end work involved. I know that some of you maybe have had problems with the VM, and if you don't have enough memory, it might be really slow. Cloudera does have the live version where you can log in and do some of these experiments on your own without having to have a VM running on your engine. So there's some of the write-ups in our reading sections of this class as well.